Good day, everyone. I am Divine Deligoro from Grade 12 Mendel. My topic for today in physics is the analysis of sinusoidal wave properties. So, our objective today is to determine the speed, wavelength, frequency, period, direction, and wave number from a given sinusoidal wave function. So, what is sinusoidal wave? A sinusoidal wave is a smooth, repeating wave that looks like a curve going up and down. It is called sinusoidal because its shapes follow a sine or cosine function. So, in an easy explanation, a sinusoidal wave is a smooth and regular wave that repeats its pattern over and over again. It's like a loop. For example, it is like a motion of a swing or the ripples in water, moving up and down smoothly and repeatedly. So that is the meaning of sinusoidal wave. And also, remember its formula, because I will tackle about that furthermore through our discussion today. So now, let's infer the following. So our sinusoidal wave has a functions, which is the amplitude, wave number, which is called also the wavelength, frequency, also called the angular frequency, period, speed, direction, and phase. Let's start with the amplitude. The amplitude is the maximum height of a wave from its rest position. It tells us how strong or intense the wave is. The higher the amplitude, the stronger will be the wave becomes. Next is the wave number. The wave number tells us how many waves can fit in 1 meter. It is related to the wavelength, which is the distance between one wave and the next. The wave number helps us to understand how tightly the waves are packed together, because the more waves in 1 meter means a higher wave number. It usually represented by a sign lambda. A wave number can be calculated using the formula k is equals to 2 pi over lambda, and it has a unit of radians per meter or rad per m. Now, let's move on to the frequency. Frequency, it tells us how fast the wave moves or vibrates in a certain amount of time. It shows how many waves pass through a point in 1 second. When we talk about the angular frequency, it means how fast the wave oscillates, and it's measured in radians per second. It can be calculated using the formula of omega is equals to 2 pi times frequency. It's because frequency is also called the angular frequency, which is they both represented by a sign omega. After frequency, we have the period. The period is the time it takes for the wave to complete one full cycle. In simple terms, it tells how long it takes for one wave to pass by. The period can be also calculated using the formula time is equals to 1 over frequency. It is measured in seconds. Next is the wave speed. Wave speed tells us how fast the wave travels from one place to another. It also shows how quickly the crest and the juice. The crest is the highest parts of the wave, while the juice is the lowest parts of the wave. The faster the wave speed, the quicker the wave pattern travels. The unit of wave speed is meter per second, which means how many meters the wave travels in 1 second. It can be calculated using the formula speed or v is equals to frequency times wave number. Now, let's talk about the direction. The direction refers to the way the wave is moving or spreading. It tells us whether the wave is traveling toward the positive side or the other opposite side, which is the negative side of the axis. When the wave moves forward, it's going in the positive direction, and when it moves backward, it's going in the negative direction. Lastly, we have the phase. The phase tells us the position or stage of the wave at a certain time. It shows whether the wave is at its crest, through, or somewhere in between. When two waves are in phase, their crests and troughs match perfectly, but when they are out of phase, their crests and troughs do not line up with each other. In most cases, the phase is zero, and that simply means the wave starts exactly at its normal starting point, or what we call the origin. When the phase is zero, it means the wave begins with on delay or shift. It starts right away from the beginning of its cycle. So, here's a formula sheet that I've prepared for you to remember all the details and like all the functions of a sinusoidal wave. I gave you this formula sheet so that you can easily follow me when I do a answering because I have an exercise to answer with for you to really understand the sinusoidal wave function. So this is the exercise. There's a problem that said a sinusoidal wave travels along a string, and there's a tree given, which is the amplitude, frequency, and the wavelength. The value of a amplitude is 0.08 meter, while the frequency is 50 Hz or Hz. The wavelength is zero point 0.4 meter. They're required to find the period, angular frequency, wave number, wave speed, and last, the wave equation. Or we can assume it as a phase. Phase is always starting at the zero, or what we call an origin. That is why its value is always a zero, but not certainly always a zero if it has a given. It depends on the problem. Now, let's start in solving our sinusoidal wave. Step 1. Find the period. So the formula of our period is t is equals to 1 over frequency. So here's our solution. Time or t is equals to 1 divided by 50, which is the given formula, which is the 50 is the frequency. When we divided it, it will answer 0.02 seconds, which means each wave cycle happens every 0.02 seconds. Step 2. Find the angular frequency. So our formula is a omega is equals to 2 pi times frequency. So our solution is omega is equals to 2 pi times 50, which is the frequency. So a pi has a value of a 3.4, which is 2 times 3.4 is equals to 6.28. While 6.28 times 50 is equals to 314.16 rad per seconds. So our angular frequency is 314.16 rad per seconds. This shows how fast the wave oscillates in radians per second. So our step 3 is to find the wave number. The formula of a wave number is k is equals to 2 pi divided by lambda. So our solution is k is equals to 2 pi, which has a value of 6.28 as we solved that earlier, over 0.4, which is our lambda, the given. So the answer is 15.71 rad per meter. This tells us how many wave cycles fit in 1 meter. So now, let's proceed to step 4, which is to find the wave speed. The formula of the wave speed is v is equals to frequency times lambda. Our solution is v is equals to 50, which is the frequency, times 0.4 is our lambda. The answer is 20 meter per second, that's the unit of wave speed. So that means that the wave travels 20 meters every second. So this is our last step, which is step 5, write the wave equation. Our general formula is y is equals to a sin kx minus lambda time plus phase, which is the phase is considered as 0. So our final answer is y is equals to 0.08 sine, which is the amplitude, times 15.71, which is the wave number, and minus 314.16 is our angular frequency. So our answer uses a minus between the wave number and the angular frequency. Therefore, our wave travels in positive x direction. That's the final answer of the exercise. So thank you guys for listening to my topic, and I hope that you learned a lot from me.